In the last course, we created this user data persister class. Now, let's back up real quick. Whenever you use a post or put endpoint, after API Platform deserializes the data into an object and validates it, it tries to save or persist that object. Usually, this means that we're saving an entity object to the database via doctrine. But we could save an object anywhere, like by sending the data to another API or putting it into Redis or Elasticsearch. API Platform doesn't really care. These things that save the object are called data persisters. So far, our two API resources, cheese listing and user, are both entities. An API Platform has special support for doctrine, including a core doctrine data persister. So whenever we make a post, put, or also patch request to an API resource that is an entity, that core doctrine data persister jumps into action and saves the object to the database. This means that normally we don't need to create our own data persisters. The core one calls persist and flush for us. But what if you need to do something right before or after an item is saved to the database? Well, you could use a doctrine listener for that. But if you want that code to only run in the context of your API, how can we? The answer is to create a custom data persister. For example, we created user data persister because we needed to encode the plain password and set it onto the password field before saving. To create this data persister, we implemented data persister interface and added a supports method that says that we support user objects. As soon as we did that, we became 100% responsible for persisting user objects. What I mean is, the normal core doctrine data persister will no longer be called for user objects. Our persister takes precedence. This is why we did our custom work up here, but then had to call persist and flush at the bottom. To prove that our data persister replaces the core persister for user objects, let's comment out the persist call and run our tests. Open tests functional user resource test. This test create user method should now fail because the user won't actually be saved to the database. Copy that method name and run Symfony run bin/phpunit --filter equals test create user. And yeah, it failed. This test passed a minute ago, but now we get a 400 bad request, which happens because the unpersisted entity is missing an ID, and so API Platform has trouble serializing it. If we put the persist back and run the test again, all better. So the fact that we are now entirely responsible for persisting the object is not really that big of a deal. But it would be even better if we could do our custom work up here and then just call the core data persister so that it can do its normal logic. And that's totally possible via decoration. Yep, instead of injecting the entity manager into the constructor, replace this with data persister interface and call it, how about, decorated data persister. Copy that and rename the variable and the entity manager property to decorated data persister. This is nice because down here, instead of persist and flush, all we need is this arrow decorated data persister, arrow persist data. Down in remove, we can do the same thing. This arrow decorated data persister, arrow remove data. Beautiful. But before we try this, don't try this unless you have Xdebug installed. Because when I run my test, it's recursion. Maximum function nesting level of 256 reached. Okay, let's figure out what's going on. In the constructor, we just said data persister interface, and Symfony apparently figured out what to pass us. This means that the data persister must be passed via autowiring. Let's go get more info about that autowired service. Run bin console debug:autowiring persister. And here it is. This is an alias for some service called Debug API Platform Data Persister. Okay, let's find more info about that service. Bin console debug container, Debug API Platform Data Persister. Okay, the class name is Traceable Chain Data Persister. The key word in the name is chain. If we dug a few levels deeper, we would find out that the data persister service actually holds a collection of data persisters inside of it. Basically, whenever something needs to be persisted, API Platform calls persist on this one data persister. Internally, it then loops over the persisters inside, calls supports on each one, and then calls persist on the first persister that supports the object. So this is really cool. If you need the entire data persister system, you can auto-wire this one service and call persist on it. The problem is that we are effectively calling ourselves. API Platform originally calls persist on the chain data persister. It calls persist on us, and then we call persist back on the chain data persister. Whoops. So instead of injecting the entire data persister system, let's inject and use just the one data persister that we know we want. The one that is normally used to save entities. We'll do that next and learn more about how the data persister system is different than some other parts of API Platform, like the context builder system.